Right, this is lesson 2 of the unit on probability and data, and we are calculating probabilities today using multiplication. We're specifically looking at probabilities of independent events today. So first we need to define what that is. So independent events in probability are events that have no effect on each other, that do not impact one another. So some examples of independent events are, like, for example, flipping a coin and then flipping it again. Those are independent events. The coin doesn't have any memory, so it doesn't remember what it was flipped to last time. So it's totally independent the next time you flip the coin. Another example would be like choosing a card from a deck and then spinning a spinner. The cards and the spinners are totally unrelated. They have no impact on one another. So there's a little formula that we have when we are calculating the probability of independent events, and we can use this instead of using a probability tree or table. It's a little bit faster. So if we have two independent events and we want to know that the probability that they both happen is, you just multiply. It's the probability of event A happening multiplied by the probability that event B happens. So that's the formula that we're going to use today. All right, so let's do some examples. Okay, so we have a set of cards here. We're going to pull two cards from this hand, replacing the first card before we pull the next. So these are independent events. Okay, so both cards, what is the probability that both cards are even numbers? Well, 3 of these cards are even. So the chances that I pull an even card on the first pull would be 3 out of 5. And then then I put that card back, and then the chance I pull another even card would again be 3 out of 5. I'm just going to multiply here. So 3 times 3 is 9. 5 times 5 is 25. This can't be reduced, so we leave it as is. Okay, next one. Probability that we pick a card that is less than 7. Well, there's only one card that's less than 7. It's 6. So that would be 1 out of 5. And then we pull a card that's greater than 7. Well, there's 3 cards that are greater than 7, so it'd be 3 out of 5. So 1 times 3 is 3. 5 times 5 is 25. So the chances we do that are 3 out of 25. Probability we pull 9 both times. Well, there's only one 9 in the deck, so the chance I pull a 9 is 1 out of 5, and then the chance I pull it again is again 1 out of 5. So the chance I do it 2 times in a row would be 1 out of 25. Neither is a 10. So if I don't want to pull a 10, there's 4 other numbers I could pull. So that would be 4 out of 5 times 4 out of 5, which would be 16 out of 25. Okay, now for part B. The question is a little bit different and a little bit trickier. It says, how would the probabilities in part A change if you did not replace the first card before pulling the next? Let's see. So, probability that both cards are even numbers. So the chances that the first card is going to be an even number is 3 out of 5. Let's say I choose 6, for example. I'm going to take one of the even cards out, and I do not replace it this time. So now I'm pulling only from a deck of 4, and there's 2 evens remaining. So the chance the next card is even is 2 out of 4. And this would be 6 out of 20, and I can reduce that to 3 out of 10. So the chance that I pull 2 even cards without replacement is 3 out of 10. Okay, let's do the next one. Probability that I choose a card that is less than 7, that is 1 out of 5, because there's only one card that's less than 7. So now the 6 is pulled out of the deck. And the chance that I pull something greater than 7 is now 3 out of 4. Because there's 3 cards that are greater than 7 out of the 4 cards that are left. So this would be 3 out of 20. Okay, so you will notice the probability is different in part A and B. Okay, Now pull the 9 both times. So chance I pull the 9 the first time is 1 out of 5. Now the 9 is gone. So the chance that I pull a 9 the second time is actually 0, because I can't pull the 9. I'm already taking it out. So the chance of this happening is 0 if I don't replace the first card. Neither is a 10. Okay, let's see. So chances I pull a card that is not 10 the first time is 4 out of 5. And then, let's say I pulled a 6. Now there are 3 cards remaining that are not 10, so it would be 3 out of 4. We can reduce this before we multiply because both of these numbers divide by 4. So the final answer here would be 3 out of 5. Remember that you can reduce before you multiply fractions. It makes it a little bit faster and easier compared to reducing at the end. Okay, last question. Common misconception here. So you have a quiz and you forgot to study. Let's say there's 3 questions on this quiz and it's multiple choice. And there's 4 choices per question. So you plan to guess on each one. You have no idea what the answer is. Let's calculate the probability that you get all questions right. People tend to think this is a little higher than it actually is. So let's see. So let's just do the probability we get the first question right. So 3 things need to happen here. Then we get the question 2 right. And then we need to get question 3 right. So chances I get the first question right would be 1 out of 4 because there's only 1 correct answer out of the 4 possibilities. Probability I get the second question right is also 1 out of 4 and then 1 out of 4. So this is 1 out of 64. 4 times 4 times 4 is 64. This is a really small percentage. It's about 1.6% chance. For only a 3 question quiz, that's pretty small chances of getting all 3 questions right. Now, what are the chances we get all 3 wrong? Chances are much higher. So it's going to be the probability we get the question 1 wrong times probability we get question 2 wrong times the probability we get question 3 wrong. So chances we get question 1 wrong are 3 out of 4. There's 3 wrong answers out of 4 that we could choose. And then 3 out of 4, and then 3 out of 4. So it's 27 out of 64, which is about 42%. So almost 50% chance you're going to get everything wrong on the quiz if you guess on all 3 questions. Okay, and that is the end of the lesson.